Welcome to the AstroGuy Podcast. I'm your host, Wayne Zuhl. July is here, and if you're in the northeastern U.S. like me, you've been dealing with lots of hot and humid weather. I don't know how the weather was in June where you live, but here in New Jersey, it feels like we experienced all 4 seasons in June. And as this is being recorded, I've only had 2 good nights of observing so far this month. Hopefully, you had it better than I did. Fortunately for all of us, there's a lot happening in the July 2025 skies. We'll check out the planets and when to catch the best views, dive into a summer meteor shower, get a quick space mission update, learn about a great new ground-based telescope, explore a trio of craters on the moon, all before diving into another batch of the best summer show-stopping deep sky objects. I want to quickly mention a video that we released earlier this month. If you've been thinking about getting involved with astrophotography or you've been imaging for years, our episode about integration time explains the concepts and shows real examples of how increasing integration time improves your images more than many other factors. We'll leave a link to it so you can check it out if you missed it. I want to let everyone know that I'm going to be moving later this year. We've sold our home and are moving to a smaller home a little further from New York City than we are now. Right now, I live in a Bortle 8/7 zone, but our new home is in a darker Bortle 5/6 area. Even better, I'll be closer to my kids and grandkids, and I'll finally have a much clearer southern horizon. It's going to be a lot of fun. The move will happen in phases over the rest of this year, and I hope to keep up the pace of publishing 2 episodes every month. If for some reason I get behind, I'll still put out the What's Happening This Month episode, but by January 2026, we should be settled in, and if needed, the regular schedule will resume. Anyway, we have a lot to cover this month, so let's dive into July's Planetary Roundup. Mercury begins July in the western sky at sunset. On the 1st, Mercury is shining at magnitude 0.4, and at 9 p.m. will appear about 10 degrees above the western horizon. Binoculars will help you spot it in the twilight glare. In a telescope, the planet shows a 44% illuminated crescent shape that spans almost 8 arcseconds wide. Each evening after sees Mercury appearing lower in the sky, but still visible. Mercury will have faded to magnitude 1.05 and will be lost in the twilight glow after about 2 weeks into July. While spotting Mercury may be tough at times, Venus is a different story altogether. This month, Venus is putting on a great show in the morning skies. On the 1st, Venus rises at 2:54 a.m. and is glowing brilliantly at magnitude -4.1. The planet is showing a gibbous phase about 64% lit and spanning just over 17 arcseconds wide. It's not the largest that we see Venus, but it's still a striking sight in a telescope. On the mornings of July 11th through the 14th, you can watch Venus pass about 3 degrees above magnitude 0.85 Aldebaran. This should be stunning to see in binoculars. On the morning of the 21st, the 15% waning crescent moon will appear about 7 degrees above Venus, making for a beautiful naked eye pairing. Rising at 2:57 a.m. on the 31st, Venus will have dimmed slightly to magnitude -3.99 and will show a 74% gibbous phase that spans just over 14 arcseconds across. Mars begins the month low in the western sky in Leo at sunset. Setting at 11:33 p.m. on the 1st, the red planet is glowing at magnitude 1.45 and shows a disk that spans less than 5 arcseconds wide. You'll need good skies and good optics, but you can still spot the polar caps and possibly some other features on the red planet. As the month goes on, Mars will fade slightly to magnitude 1.58 and will appear smaller than 4.5 arcseconds wide. Each evening, Mars will appear lower on the horizon. As summer progresses, Mars will sink lower each evening until it eventually disappears into the twilight. At 9 p.m. on the evening of the 28th, look to the west and spot Mars about 3 degrees to the right of the 18% waxing crescent moon. This should be a beautiful sight with the naked eye, binoculars, or even a wide-field scope at low power. By the 2nd or 3rd week of July, Jupiter should be visible in the eastern sky about 40 minutes before sunrise. Jupiter is in Gemini and glowing at magnitude -1.9. and showing a disk that spans 32 arcseconds wide. As the year goes on, Jupiter will rise earlier, and this fall and winter it will be putting on a great show in the evening skies. On the morning of July 23rd, if you have clear skies and a good eastern horizon, you'll be in for a treat as the very thin 2.5% waning crescent moon will appear 5 degrees to the left of Jupiter. At 5 a.m., the pair will only be about 8 degrees above the horizon. This is a very old, razor-thin crescent moon that is barely illuminated. Likely you'll need binoculars to spot the moon in the growing twilight glow. At the end of July, Jupiter rises at 3:42 a.m. and offers early risers a decent view of what's coming up later in the year. On July 1st, Saturn rises about 30 minutes after midnight. The planet is shining just below first magnitude and shows a disk that spans almost 18 arcseconds across. And when you include the rings, the whole system spans about 41 arcseconds wide. Saturn spends all month in Pisces. By the end of the month, the ring planet will have brightened to magnitude 0.8, and it will appear slightly larger, now spanning just over 43 arcseconds wide. Around 2 a.m. on the morning of the 16th, the 70% illuminated waning gibbous moon will appear a little more than 2 degrees above Saturn in the southeastern sky. You'll want to stay up or get up to see it. It should be a stunning sight to witness. Uranus begins July well placed in the morning skies, 4 degrees to the left of Venus, which outshines Uranus by a lot. Uranus is glowing dimly at magnitude 5.83, making it an easy binocular object. The planet appears small, spanning about 3.5 arcseconds across. By the morning of the 6th, Uranus will be about 3 degrees above Venus. As the month goes on, Uranus rises earlier each morning. On the morning of the 20th, the 24% crescent moon will be about 4 degrees above Uranus. With wide-field binoculars, this could look really interesting. Will the bright moon wash out dimmer Uranus? You'll have to try it and let us know in the comments. As July ends, Uranus rises at 12:59 a.m., and by 3 a.m. will be around 20 degrees above the horizon, and it will have brightened slightly to magnitude 5.79, although it still appears about the same size and is still in Taurus, just a few degrees south of the Pleiades. Neptune, which can be difficult to find because it's so faint, is actually a little bit easier to find this month. Use bright Saturn as your guide. Just scan about 1 degree north and you should see dim Neptune. The most distant planet in our solar system will be glowing faintly at magnitude 7.7, and you'll need binoculars or a telescope to spot it. It will remain around the same brightness and will only span about 2.3 arcseconds across. On the morning of the 16th, Neptune will be nearly impossible to spot, with the extremely bright waning gibbous moon only 1.5 degrees away from dim Neptune. This July, the only major meteor shower of note is the southern Delta Aquariids. This shower peaks on the night of July 29th going into the 30th. The best shot at witnessing these meteors will be after midnight on the morning of the 30th, when the radiant will be more than 30 degrees above the southern horizon. Observers under dark skies with the radiant overhead could see as many as 25 meteors per hour. However, those not in the tropics can expect to see fewer than that. This year, the waxing crescent moon will have set before the radiant is high in the sky, making for a good year to try to see these meteors, which were left behind during a close passage of Comet 96P Machholz. The moon will interfere with next month's Perseids, so try to spot these if it's clear where you are. As this episode is being produced, there are no comets brighter than 13th magnitude that are currently visible. Our space mission update this month includes a ground-based project that is pretty wild. We'll get to that in a moment. June saw some interesting things happen in the world of space missions. Unfortunately, the iSpace Resilience lunar lander ended in failure when it lost communications and crashed into the lunar surface, ending the mission early and abruptly. SpaceX saw Ship 36 explode in a RUD, or Rapid Unscheduled Disassembly, during a static test fire, setting back the 10th flight of the Starship. SpaceX has had several failures with Starship this year, but hopefully they will learn from previous mistakes, and when Test Flight 10 finally takes place, it will be successful. The Axiom 4 mission, that is sending 4 private astronauts to the ISS for a 2-week research mission, has experienced several delays, but was successfully launched on the morning of June 25th, and on the morning of the 26th, Axiom 4 docked with the ISS, and now its crew is conducting their experiments. And last, but definitely not least, is an important update about an incredible ground-based observatory that has just released its first images as this episode was being produced. I'm referring to the Vera C. Rubin Observatory, which houses an 8.4 meter telescope, which has a nearly 28-foot wide primary mirror. The telescope has one of the largest, if not the largest, camera sensor ever made. The sensor spans 64 centimeters, more than 2 feet wide, and it collects 3.2 gigapixels per image. That is a huge amount of data, considering that most camera sensors are measured in megapixel, making this sensor thousands of times larger than the sensor in your phone or DSLR. The reason for this huge sensor is its ability to image the entire southern sky from the observatory in 3.5 degree wide patches, using a variety of filters to isolate various wavelengths. In July, we're going to release an entire episode about the Vera C. Rubin Observatory and dive into who Vera Rubin was and what this amazing instrument plans to accomplish, so look out for that. Now it's time for the Lunar Feature of the Month. If you've ever explored the moon with a telescope around first or last quarter, chances are you've come across one of the most eye-catching crater groupings on the entire lunar surface: Theophilus, Cyrillus, and Catarina. Nestled along the western edge of Mare Nectaris, the Sea of Nectar, this trio of overlapping craters creates a dramatic, sculpted landscape that never fails to impress. The 3 craters are named after influential scholars of antiquity, whose legacies now live on not just in books, but now carved into the battered surface of the moon. Let's start with Theophilus, named after Theophilus of Alexandria, a 4th and 5th century Christian patriarch and the 23rd Pope of Alexandria, who is best known for his scholarly influence during the early Byzantine Empire. Theophilus crater is the youngest and most prominent of the 3. It spans 101 kilometers, about 62 miles wide, and plunges nearly 4,200 meters, around 14,000 feet deep. This is a standout lunar feature. Its sharply terraced walls and dramatic central peak complex, which rises about 1,400 meters from the crater floor, make it a favorite target for both visual observers and lunar photographers. Theophilus likely formed 1 to 3 billion years ago, well after Mare Nectaris was flooded by basaltic lava. Theophilus' crisp, well-defined appearance tells us it's relatively young. The central peaks, raised from the violent rebound of the surface after the impact, may expose material from deeper within the moon's crust, giving planetary scientists a window into the moon's internal structure. Located just southwest of Theophilus is Cyrillus, named for Cyril of Alexandria, nephew and successor of Theophilus, and a major figure in early Christian theology. Cyrillus spans about 98 kilometers, just over 60 miles wide, and is roughly 3,600 meters deep, around 12,000 feet. It's significantly older than Theophilus, around 3.9 billion years, and much more eroded. Cyrillus has been partially flooded and heavily worn down by impacts. The western wall has been disrupted by the overlapping rim of Theophilus, giving a striking sense of geological sequence. Cyrillus has modest central peaks, but they're subdued, hinting at its age and the many billions of years of bombardment it's ensued. Just south of Cyrillus lies Catarina, the southernmost of the trio. It's named after St. Catherine of Alexander, a scholar and Christian martyr revered throughout medieval Europe. While the details of her life are debated by historians, her influence on religious and educational traditions are well documented. Catarina spans about 100 kilometers or 60 miles wide and is roughly 3,100 meters or just over 10,000 feet deep. It's believed to be more than 4 billion years old, making it one of the oldest visible features on the moon. Catarina lacks a central peak, and its battered walls and pockmarked floor tell the story of the moon's early years when impacts were much more violent and frequent. The best time to observe this trio is when the moon is between 5 and 7 days old, just before first quarter. At this phase, low-angle sunlight casts long shadows across the terrain, beautifully highlighting ridges, slopes, and the layered overlap between craters. Binoculars can show you the region, but to really appreciate the details, like the overlapping rim of Theophilus and Cyrillus, you'll want a 4-inch or larger telescope at least 75 to 100 power. Under good seeing conditions, higher magnification will reveal even more intricate detail across these craters. So the next time you're scanning the waxing crescent or first quarter moon, take a moment to find Theophilus, Cyrillus, and Catarina. You'll be looking at billions of years of lunar history, etched into the surface by ancient impacts and revealed through the simple power of light and shadow. Alright, it's time to leave the solar system and dive into some of the best deep sky objects visible on warm summer evenings. Last July we explored a handful of great showcase targets, and this month we've got another round of celestial gems for you to enjoy. We'll start in Canis Venatici with the brilliant globular cluster Messier 3. Located about 33,900 light-years away, M3 is made up of more than 500,000 stars and is about 11.4 billion years old. It shines at magnitude 6.2, which makes it technically visible to the naked eye from a very dark site, but binoculars or a small telescope will reveal it much more easily. In binoculars, M3 looks like a slightly fuzzy star. Through a 4-inch scope, you'll start to notice its bright core with a grainy halo. Step up to a 6-inch or larger instrument and increase the magnification, and now the outer regions will begin to resolve into individual stars, hundreds of them, sparkling like cosmic glitter. One fascinating thing about M3 is that it contains more than 270 known variable stars, more than any other globular cluster we know of. Most of these are RR Lyrae variables, which astronomers use to measure distances across the galaxy. It's not just a beautiful object, it's a scientifically important one as well. Deep sky imagers enjoy M3, as there are several small, faint galaxies that lie beyond the cluster. Most of the galaxies are fainter than 16th magnitude and small, so they're not really visual targets. I recently shot this image of M3, and there are at least 9 galaxies visible in this image that's less than half a degree wide. As you can see here, most of them appear stellar, but there are some spiral galaxies that are seen in the image as well. To find M3, start at Arcturus in Bodies and look east toward Cor Caroli in Canis Venatici. M3 sits nearly halfway between the two, slightly closer to Arcturus. It'll show up as a round misty glow. Zoom in and take your time with it. This one always delivers. The next showcase object that we'll explore this month is one of the sky's most iconic and rewarding deep sky objects, Messier 16, commonly known as the Eagle Nebula. M16 is located in the constellation Serpens Cauda, the tail of the serpent, and it's 2-for-1, being comprised of an open cluster and a richly detailed emission nebula. The cluster itself lies about 7,000 light-years away and spans roughly 15 arc-minutes across and contains more than 8,000 stars. The nebula is larger, at around 70 by 50 arc-minutes in size, and the complex glows around magnitude 6. That means that you can easily spot the cluster under dark skies with binoculars, but the nebula really shines through in photographs or with a telescope and a nebula filter. At the eyepiece, what you'll see depends on your equipment and your skies. In smaller scopes under light-polluted conditions, you'll mostly pick up the cluster, about 20 or so loosely grouped stars. But under darker skies, or with the help of an O3 or UHC filter, you'll start to pick up the faint glow of the surrounding nebula, which extends well beyond the core cluster. This is where the magic happens. You may know this region for the Pillars of Creation, made famous by the Hubble Space Telescope. These are towering columns of dust and gas where new stars are forming in regions called Bok globules. Though they're tough to spot visually, just knowing that they're there adds a sense of depth and wonder to your enjoyment in observing this object. To find M16, start at Caus Borealis, the star marking the top of the Teapot asterism in Sagittarius. From there, sweep about 11 degrees north and 2 degrees west, and you'll be looking right at the Eagle Nebula. The next object on our tour is a little farther south than Sagittarius. I'm referring to M20, which is commonly known as the Trifid Nebula. Messier 20 is a fascinating combination object, a bright emission nebula, a reflection nebula, and a dark nebula, all tangled together. It's located about 5,200 light-years away and spans roughly 28 arc minutes, while glowing at magnitude 6.3, which puts it well within the reach of binoculars and small telescopes under dark skies. Through binoculars, M20 appears as a faint, soft glow, but even in a modest telescope, you'll start to make out more of its structure. What makes the Trifid so compelling is the dark dust lanes that split the nebula into 3 distinct lobes, hence the name Trifid. In long exposure images, the reddish-pink glow comes from hydrogen gas being excited by young, hot stars, while the bluish area to the north is starlight reflecting off of dust. It's one of those objects where astrophotographers can really show off, but visual observers will still find a lot to enjoy. If you're viewing from a location with light pollution, try using a light pollution filter. It can really help boost the contrast and bring out those dark lanes. In a 6-inch or larger scope from a dark site, those dust lanes become more obvious, especially when using averted vision and at lower magnifications. Locating M20 is fairly easy. From 3rd magnitude Alnazi, the star marking the tip of the teapot spout in Sagittarius, sweep half a degree west and then 7.5 degrees north, and you'll spot it. If you can find M8, the Lagoon Nebula, which we discussed in last July's summer showcase, M20 lies just about 1.5 degrees north of M8. The two often fit together in a low-power field of view, making for a stunning pairing in wide-field scopes and binoculars. Next up on our tour is a globular cluster that's often overshadowed by its more famous neighbor, Messier 13, but it really deserves more attention. I'm talking about Messier 92, located in the constellation Hercules. M92 sits about 26,700 light-years from us, and it is one of the oldest and most metal-poor globular clusters known, with an age estimated at around 13.8 billion years, making it nearly as old as the universe itself. M92 shines at magnitude 6.4 and spans 14 arc minutes in size. It's easily spotted in binoculars or even a finder scope as a small fuzzy patch. In small telescopes, M92 appears as a brightish, compact ball of light with a sharply concentrated core. Even a 4-inch scope under decent skies will begin to resolve the outer edges into a sprinkling of faint stars. With a 6 to 8-inch telescope and moderate to high magnification, you'll start to resolve quite a few of the cluster's stars, especially toward the edges, giving it a grainy, almost sparkling texture. It's a great object to compare side by side with nearby M13, and even though it's often overlooked, many observers, myself included, find M92 to be just as striking, especially under a dark sky. If it weren't sitting in the same constellation as M13, this one might get a lot more fanfare. Either way, it's absolutely worth a visit when you're looking at summer showcase objects. To locate M92, start at the keystone asterism in Hercules. You know those 4 stars that form the body of the strongman? Begin at the northernmost star of the keystone, Eta Herculis, and sweep less than 8 degrees north-northeast and you'll spot M92. Next up is a fan favorite, Messier 57, better known as the Ring Nebula, located in the constellation Lyra. M57 sits about 2,600 light-years from Earth and spans 1 light-year across, which correlates to just under 4 arc minutes at around 230 arc seconds wide. It shines at about magnitude 8.8, putting it within reach of even modest backyard scopes under decent skies. While it's called the Planetary Nebula, it actually has nothing to do with planets. It's actually the remnants of a sun-like star that shed its outer layers at the end of its life, leaving behind a hot white dwarf at the center, surrounded by a glowing ring of ionized gas. Visually, M57 is one of those objects that wows observers at every level. In a small telescope, it appears as a tiny smoke ring or a grayish oval, like a ghostly Cheerio, just floating in space. In my 8-inch SCT under dark skies, the structure becomes clearer, and the outer ring appears brighter and more sharply defined, while the center stays dim and more diffuse. If you're observing under light-polluted skies, an O3 or UHC filter can really help. These filters bring out more contrast in the nebula, making the ring stand out sharply against the background. And observing it under really steady skies with high magnification can reveal subtle structure within the ring itself. The central star, a faint magnitude 15.3 white dwarf, is a challenge, usually only visible in larger scopes and under excellent seeing conditions. But even without spotting it, this nebula is a true showpiece and deserves lots of time observing it. Finding the ring nebula is absolutely simple. Just look for the parallelogram-shaped body of Lyra. You'll find Chiliac and Sulafat, the two bright stars forming the southern edge of the parallelogram. M57 sits almost exactly midway between them, just slightly north of the line connecting the two. In binoculars, it might look like a slightly bloated star, but once you get a telescope on it, the ring shape is unmistakable. The next object on our tour is a little bit of a lesser-known gem that's easy to overlook, but it is one of my very favorite summer open clusters to observe. I'm talking about Messier 29, an open cluster nestled in the rich star fields in Cygnus, the Swan. M29 is located about 5,240 light-years from Earth and shines at magnitude 7.1, making it an easy target for binoculars or any small telescope. It's a compact group, only about 7 arc-minutes wide, so while it's not the most expansive cluster out there, it's nicely framed in a low to medium power eyepiece. In my 70mm refractor, M29 reveals itself as a small, tight knot of stars. It's sometimes described as a sort of box or cross shape. There are about a half dozen brighter stars arranged in a rough square, with a few fainter ones scattered around the edges. It's not the kind of cluster that overwhelms you with star density, but it does have a quiet elegance, especially when observed against the rich backdrop of the Milky Way. In my 8-inch SCT, this cluster is fun to observe, as with continued observations, more stars become visible, making this a really fun object. This isn't the kind of object that demands attention the way M13 or the Ring Nebula does, but it's a great stop along the way, especially if you're hopping through the Milky Way. Think of it as one of those quieter clusters that rewards a slower, more thoughtful look. It's a perfect object to revisit on a warm summer night when you're taking a tour through the heart of Cygnus. To find M29, start at Gamma Cygni, also known as Satyr, the star at the heart of the Northern Cross asterism in Cygnus. From Satyr, sweep just under 2 degrees south-southeast and you'll spot M29. The last object on our tour will be best seen later in the evening or later in the summer, as it is further east in Pegasus. To check out a true showpiece of the late summer sky, M15, one of the oldest and most densely packed globular clusters in the entire sky. Located about 35,700 light-years from Earth, M15 shines at magnitude 6.2 and spans 18 arc-minutes across, making it bright enough to spot in binoculars, and in any telescope, it is a stunner. What's remarkable about M15 is just how tightly concentrated its core is. It is one of the densest of any known globular clusters. It's actually classified as a core collapse globular, meaning gravity has pulled its stars into an incredibly tight, compact center. In binoculars, M15 appears as a small fuzzy patch. From a dark sky with my 70mm refractor, the cluster appears as a concentrated core, surrounded by a halo of unresolved fainter stars. With my 8-inch Dob under dark skies, M15 is an absolute treat. The core is bright and compact, and you can start to resolve the outer regions into individual stars. With extended observations, hundreds of stars will become visible. M15 is also home to a planetary nebula, Peas 1, the first to be discovered in a globular cluster, but at magnitude 15.5, it's way beyond the visual reach for most amateur telescopes. Still, it's an interesting piece of trivia that adds to M15's already fascinating resume. To locate M15, start at magnitude 2.35 Enif, also known as Epsilon Pegasi. From there, move about 4 degrees northwest, and M15 will come into view. It's easy to find, and once you see it, you'll understand why it's such a favorite among deep sky observers. That wraps up our Deep Sky Tour for July. I hope these showcase objects inspire you to spend more time under the stars and discover some new favorites of your own. Thank you so much for joining me. I hope this episode was fun, informative, and inspires you to get outside and look up. If you've got questions, feedback, or ideas for future episodes, shoot me an email at astroguypodcast@gmail.com or leave a text or a voicemail at 973-404-0380. Be sure to check out the AstroGuy Podcast group on Facebook and visit our YouTube channel for past episodes, observing tips, and bonus content. If you found this episode helpful, please like, subscribe, comment, and share. It really helps us to grow. And if you'd like to support the AstroGuy Podcast, you can buy us a cup of coffee. Your support helps us keep the mics and computers on and the telescopes pointed skyward. The link is in the show notes. Until next time, may your skies be clear. And as always, carpe noctem, seize the night.
I'm Zuhl, and this was the AstroGuy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe noctem. Seize the night.